National Electrical Code, or NEC, generally allows a maximum of 42 circuits per panel. However, there are some exceptions that may apply based on factors such as the type of panel and the circuit breakers used within that panel. Understanding how to determine the maximum circuits involves different interpretations of the NEC. One interpretation of the NEC indicates that each pole of a multi-pole circuit breaker should be counted as a separate circuit. Considering this interpretation, a panel with 6 one-pole breakers, 7 two-pole breakers, and 10 twin single-pole breakers would have a total of 42 circuits, calculated as 6 plus 7 multiplied by 2 plus 10 multiplied by 2, equaling 42. Another interpretation suggests that multi-pole circuit breakers should be counted as a single circuit, regardless of the number of poles. Under this interpretation, the same panel configuration, with 6 one-pole breakers, 7 two-pole breakers, and 10 twin single-pole breakers, would have only 23 circuits, calculated as 6 plus 7 plus 10 equaling 23. To ensure compliance with applicable electrical codes, it is recommended that you consult with a qualified electrician. An electrician will have the expertise to determine the maximum circuits allowed for your specific panel, taking into account all relevant factors and local regulations. When you're looking at this, it is important to understand the different types of circuit breakers used in electrical panels because they play a crucial role in electrical safety and circuit management. Firstly, single-pole breakers are the most common type and are typically used for 120-volt circuits. They occupy one slot in the electrical panel and protect a single hot wire. Secondly, double-pole breakers are used for 240-volt circuits that require 2 hot wires. These breakers take up 2 slots in the panel and provide simultaneous protection to both wires. Thirdly, twin single-pole breakers, also known as tandem breakers, are designed to fit 2 circuits into a single panel slot. They are used to increase the number of circuits in a panel without increasing the physical size of the panel itself. The NEC has specific requirements related to the installation and use of these breakers, so it is important to verify that they comply with the local electrical codes and are suitable for the panel in question. Several factors affect the maximum number of circuits allowed in an electrical panel. These factors are based on the NEC and other relevant standards. The NEC sets the maximum number of circuits that can be installed in a panel. This limit is generally set at 42 circuits, but it can vary depending on the specific panel design and local codes. The physical size of the panel and the spacing between the breakers also play a role. Panels are designed to accommodate a specific number of breakers, and overcrowding can lead to overheating and other safety hazards. The panel's ampacity, which is the maximum amount of electrical current the panel can safely handle, is another critical factor. The total load on all the circuits in the panel must not exceed the panel's ampacity rating. Local electrical codes and regulations can also impact the number of circuits allowed. These codes may have additional restrictions or requirements that must be followed. It is important to ensure compliance with all applicable codes to maintain safety and avoid violations. When determining the maximum number of circuits, it is important to consider the different interpretations of the NEC regarding multi-pole breakers. As mentioned earlier, some interpretations count each pole of a multi-pole breaker as a separate circuit, while others count the entire breaker as a single circuit. The correct interpretation depends on the specific application and local code. For example, if each pole of a 2-pole breaker is counted as a separate circuit, a panel with 6 single-pole breakers, 7 two-pole breakers, and 10 twin single-pole breakers would be calculated as 6 plus 7 multiplied by 2 plus 10 multiplied by 2, resulting in 42 circuits. Alternatively, if multi-pole breakers are counted as a single circuit, the same panel would be calculated as 6 plus 7 plus 10, resulting in 23 circuits. Remember that it's crucial to understand which interpretation applies in your jurisdiction to accurately determine the maximum number of circuits allowed in your electrical panel. Another thing to consider is the load calculation. This is a vital step in electrical panel management. It involves estimating the total electrical demand and the panel to ensure it does not exceed the panel's capacity. This is critical for preventing overloads, which can lead to overheating, damage to equipment, and potentially electrical fires. To perform a load calculation, firstly, you must identify all the circuits connected to the panel. This includes lighting circuits, appliance circuits, and any other circuits that draw power from the panel. Secondly, determine the load on each circuit. This can be done by looking at the wattage or amperage rating of the devices connected to the circuit. For example, a lighting circuit may have several light fixtures, each with a specific wattage. An appliance circuit may power a refrigerator, microwave, or other appliance with a known power consumption. Thirdly, apply demand factors where applicable. Demand factors are used to account for the fact that not all circuits will be operating at their maximum load simultaneously. For example, a residential lighting circuit may only be used at full capacity for a few hours each day. Demand factors are specified in the NEC and vary depending on the type of circuit and the application. Fourthly, calculate the total load on the panel. This is done by summing up the loads on all the circuits, taking into account the demand factors. The total load should be less than the panel's ampacity rating. If the total load exceeds the panel's capacity, you will need to redistribute the loads or upgrade the panel to a higher ampacity rating. Overloading a panel can cause the circuit breakers to trip frequently, which can be inconvenient and disruptive. It can also damage the electrical system and increase the risk of electrical fires. In addition to load calculations, it is also important to consider the balance of loads across the different phases of the electrical panel. In a single-phase panel, the loads should be distributed as evenly as possible between the two phases. This helps to prevent imbalances that can cause voltage fluctuations and equipment damage. To balance the loads, firstly, you need to identify the circuits connected to each phase of the panel. This information is typically indicated on the panel's wiring diagram. Secondly, calculate the total load on each phase. This is done by summing up the loads and the circuits connected to each phase. Thirdly, compare the loads on the two phases. The goal is to have the loads as close to equal as possible. If there is a significant imbalance, you can redistribute the circuits to achieve a better balance. This may involve moving circuits from one phase to another or adding new circuits to the less loaded phase. Balancing the loads can improve the efficiency of the electrical system and reduce the risk of equipment damage. It can also prevent voltage drops and ensure that all devices receive the correct voltage. If you are not comfortable performing load calculations or balancing the loads yourself, it is best to consult with a qualified electrician. An electrician can perform these tasks safely and accurately and ensure that the electrical panel is operating within its capacity. Another important aspect of electrical panel management is proper wiring and connections. The wiring and connections in an electrical panel must be properly installed and maintained to ensure safe and reliable operation. Loose or corroded connections can cause overheating, voltage drops, and even electrical fires. To ensure proper wiring and connections, firstly, use the correct wire size for each circuit. The wire size must be appropriate for the amperage rating of the circuit. Using undersized wires can cause overheating and potentially electrical fires. Wire sizes are specified in the NEC Table 310.15b16 and other relevant tables. Secondly, make sure all connections are tight and secure. Loose connections can cause arcing and overheating. Use the proper tools to tighten the connections and ensure that they are properly torqued. Thirdly, protect the wires from damage. Wires should be properly supported and protected from physical damage. Use conduit or other protective measures to prevent wires from being cut, crushed, or otherwise damaged. Fourthly, label all circuits clearly. Each circuit in the panel should be clearly labeled with its intended use. This makes it easier to identify and troubleshoot circuits when needed. Fifthly, inspect the wiring and connections regularly. Electrical panels should be inspected regularly for any signs of damage or corrosion. Loose connections should be tightened, and damaged wires should be replaced. If you are not comfortable working with electrical wiring, it is best to consult with a qualified electrician. An electrician can perform these tasks safely and accurately and ensure that the wiring and connections in the panel are in good condition. Another thing to think about is circuit breaker maintenance and replacement. Circuit breakers are essential safety devices that protect electrical circuits from overloads and short circuits. They are designed to trip and interrupt the flow of electricity when a fault occurs, preventing damage to equipment and reducing the risk of electrical fires. To ensure that circuit breakers are functioning properly, firstly, test the breakers regularly. Circuit breakers should be tested periodically to ensure that they are tripping properly. This can be done using a circuit breaker tester or by manually tripping the breaker. Secondly, replace faulty breakers. If a circuit breaker fails to trip when it should be replaced immediately. Faulty breakers can be a safety hazard and should not be relied upon. Thirdly, use the correct type of breaker. Circuit breakers come in different types and amperage ratings. It is important to use the correct type of breaker for each circuit. Using the wrong type of breaker can compromise safety and potentially damage equipment. Fourthly, avoid overloading circuits. Overloading a circuit can cause the circuit breaker to trip frequently. This can be inconvenient and can also damage the breaker over time. Make sure that the total load on each circuit does not exceed the breaker's amperage rating. Fifthly, keep the breakers clean and dry. Circuit breakers should be kept clean and dry to prevent corrosion and ensure proper operation. Dust, dirt, and moisture can interfere with the breaker's ability to trip properly. Sixthly, label each breaker clearly. Each circuit breaker in the panel should be clearly labeled with its intended use. This makes it easier to identify and troubleshoot circuits when needed. Replacing a circuit breaker is a relatively simple task, but it should be done carefully and according to the manufacturer's instructions. Firstly, turn off the power to the circuit. Before replacing a circuit breaker, turn off the power to the circuit at the main breaker. This will prevent electric shock. Secondly, remove the panel cover. Remove the panel cover to expose the circuit breakers. Be careful not to touch any of the wires or connections inside the panel. Thirdly, identify the faulty breaker. Locate the faulty breaker that needs to be replaced. It may be labeled or have a tripped position. Fourthly, remove the faulty breaker. Use a screwdriver to loosen the screws holding the faulty breaker in place. Then carefully pull the breaker out of the panel. Fifthly, install the new breaker. Insert the new breaker into the panel and tighten the screws to secure it in place. Make sure the breaker is properly aligned and seated in the panel. Sixthly, replace the panel cover. Replace the panel cover and tighten the screws. Seventhly, turn on the power to the circuit. Turn on the power to the circuit at the main breaker and test the new circuit breaker to make sure it is functioning properly. If you are not comfortable replacing a circuit breaker yourself, it is best to consult with a qualified electrician. An electrician can perform this task safely and accurately and ensure that the new breaker is properly installed. When working with electrical panels, it is crucial to prioritize safety. Electrical work can be dangerous, and it is important to take the necessary precautions to prevent electric shock, burns, and other injuries. Firstly, always turn off the power. Before working on any electrical circuit, turn off the power to the circuit at the main breaker. This will prevent electric shock. Secondly, use insulated tools. Use insulated tools when working on electrical circuits. Insulated tools will protect you from electric shock if you accidentally touch a live wire. Thirdly, wear safety glasses. Wear safety glasses to protect your eyes from sparks, debris, and other hazards. Fourthly, avoid working in wet conditions. Avoid working on electrical circuits in wet conditions. Water can conduct electricity and increase the risk of electric shock. Fifthly, test circuits before working on them. Before working on any electrical circuit, test the circuit to make sure it is energized. Use a voltage tester to verify that there is no voltage present. Sixthly, follow the NEC and local codes. Follow the NEC and local electrical codes when working on electrical circuits. These codes provide guidance on safe wiring practices and procedures. Seventhly, consult with a qualified electrician if needed. If you are not comfortable working on electrical circuits, or if you are unsure about any aspect of the work, consult with a qualified electrician. An electrician can perform the work safely and accurately and ensure that the electrical system is functioning properly. By taking these safety precautions, you can minimize the risk of electrical accidents and ensure a safe working environment. Electrical panels are an essential part of any electrical system, providing a central point for distributing power to different circuits. Understanding how to manage and maintain electrical panels is crucial for ensuring electrical safety and reliability.